Module 10.1, we're going to go over how to understand, write, and evaluate conditional probability. Our first table, we're asked how many students were in the survey. I'm going to add all of those values together. To equal 1,000. It then asks, what were the students asked? Do you take choir or band? How many students were in both choir and band? How many students are not in either choir or band? What is the probability that a randomly selected student would be in band? In band, there are 50 plus 225, which equals 275 out of the total. If I enter this in on my calculator, it'll give me 0.275, which will be 27.5%. Example 2. What does the 95 in the center tell you? 95 students take all 3 classes: music, art, and foreign language. What does the 145 tell you? $145 students take music and art. How many total students are represented in the diagram? $450 plus 145 plus 200 plus 7. I add these all together and we get 1,325 students. Which elective class has the least number of students enrolled? Music has 450 plus 125 plus 95 plus 145. Art has 145 plus 95 plus 80 plus 200. And foreign language has 125 plus 95 plus 80 plus 230. So the elective class with the least number of students enrolled would be art. In our tree diagram, I'm going to look for the totals. The total batters would be 1,193 plus 417. When I want right-handed pitcher, it'd be 500 plus 255. When I want left-handed pitcher, it'll be 693 plus 162. We are going to use this information to answer the following questions. Based on this data, if you are a left-handed batter, what is the probability that you will face a right-handed pitcher? The probability of having a right-handed pitcher over a left-handed batter. So I would write 255 out of 417. If you want to write the percent, 255 out of 417 is 61% chance. Based on this data, right-handed batter, what is the probability we'll face a left-handed pitcher? That would be 693 over the 1,193. If you want the percentage, 693 divided by 1193 is a 58% chance. Based on this data, what is the probability a batter will face a pitcher of the same hand? Left on left or right on right? This is a little bit of a different one. Left is 417, on left, and the probability for right on right, and if I want the percentage, 662 divided by my total, 41%. What is the probability that a left-handed pitcher will be throwing for any given plate? Left-handed pitchers, there are a total of 855 out of my total. Percentage is 53%. What is the probability that a left-handed batter would be at the plate for any given appearance? Left-handed batter is 417. Out of the total. $417 out of the total is round up to 26%. What observations do you make about the data? Is there any amount that seems to be overly abundant? What might account for this? Answer this question in your own words. We are given a table. I have patient has TB, 380. Patient does not have TB, 620. That means the total surveyed is 1,000. If I want to know how many tested positive, I would add 361 plus 62. Test negative, I would add 19 and 558. When I redo my tree diagram, it wants how many tested positive. Tested positive would be 423. When they want tested negative was 577. I then split it up into TB and not TB. So when I look, how many tested positive and have TB? 361. Then I need tested positive and not TB. 62. Tested negative, have TB. 19. And then we have tested negative, not TB. We'll go right here. Okay. Having these tree diagrams drawn in two different ways will be helpful on the next section with probability. What is the probability that the person pulled from the data will have TB? Patient has TB is right here. That's 380 out of 1,000, which is 38%. How many don't have TB? 620. Out of 1,000. 62%. Now when we have these lines, we have to be careful. It's going to section off, don't have TB, patient does not have TB, and then our top number will be the tested negative portion. This is our top, and this is the bottom of the fraction. So we will write 558 out of the total 620 for the total that did not have it. And that is 90%. Don't have TB, that's this same category. Tested positive, this time I'm using this for my top of my fraction. 62 out of 620. 62 out of 620 is 10%. Tested positive. I'm going to use this one up here. Tested positive for my total. Have TB. This is my top number. 361 out of my 423. 85% if you entered it on your calculator. Has TB. Patient has TB. Tested negative. That goes to this section. 19 out of the 380. Tested negative, I'm going to go up here. Tested negative, has TB. 19 goes on top. $19 out of $577 is 3%. Has TB and tested positive. Tested positive and has TB. There's 361 out of my total. There's no line. There's no line, so it's out of my total, which is 1,000. 36.1%. Has TB. Has TB. Tested positive. $361 over 380, which is a 95%. Write a statement based on the diagram from the following probabilities. I have 577 out of my total. 577 comes from 577, tested negative. $62 is the not TB over 423, which was tested positive. And for the 85%, I'm going to go up here. I'm going to copy have TB tested positive. Based on the probability statement that could be made from either tree diagram, what would you say to a friend regarding the validity of the results if they are tested for TB using a skin test and the results come back positive? What would you say? In this situation, explain the consequences of errors. Write in your own words what those consequences would be. If a health test is not 100% certain, why might it be beneficial to have the results lean more toward a false positive, which means that the test indicates that you have the disease when you don't? In your own words, answer that question. Example 5, find the probability of achieving success with each of the events. Rolling an even number on a standard 6-sided die. 1, 2, 3, 4, 5, 6. Those are the numbers on a die. These are the even ones. That's 3 out of 6 probability, or 1/2 if you reduce. Drawing a black card from a standard deck. That's 52 cards, and then there are 26 that are black. Or you can say that half the deck is black if you reduce. Flipping a coin and getting heads 3 times in a row. If I flip a coin, it's 1 out of 2 probability it will land on heads. If I do it 3 times, that would be 1 times 1 times 1, 2 times 2 times 2, 1 out of 8 chance of having them all 3 be heads. Rolling a die and getting a 4. Here are all my sides. Probability of rolling a 4 is 1 out of 6. Drawing an ace. There are 4 aces in a deck. 4 out of 52. Or you can reduce it to 1 out of 13. Rolling a die twice in a row and getting 2 3s. That would be probability of rolling it first would be 1 out of 6 that it lands on a 3. 1 out of 6 again that it lands on a 3, which is 1 times 1, 1. 6 times 6 is 36. Pull out a red marble from a bag containing 3 blue, 2 red, and 5 white. So my total is 10 marbles in the bag. I'm reaching into the bag. There are 2 red out of the 10, which means I could get 1/5 chance. If you want a percentage, 20% chance that you get a red marble. You are more likely to get a white. If you have any questions, let me know.